Hello everyone. Today we're going to learn how to calculate density. We're going to do problems 1, 3, 5, and 7 together. Then you can finish the worksheet on your own. If you need more help, just contact me and I'll be glad to set up a Zoom meeting with you. First, the formula for density is found on the second page of your reference table. You'll see that density is equal to mass divided by volume. If you forget what these letters mean, they're defined out to the side. So, density is mass divided by volume. Density, mass is in grams, or lowercase g. Volume is either in milliliters, lowercase m capital L, or it's in cubic centimeters. Then density is either grams per milliliter or grams per cubic centimeter. I want to show you a really easy way to do the math. If you hate math, you're going to love this trick. You can use this in this class, in your math classes, anytime you have a math problem in this format. First of all, you draw a very large triangle. You'll divide the triangle into 3 sections. When you look at the formula, you first have to say, all right, is there multiplication or is there division in this formula? In this one, obviously there's division. The m is over the v. So when you put this formula into the triangle, you put the m over the v. Then put the d in the leftover blank, which happens to be on the bottom. Now, when you calculate, if you are trying to find the density, you take the mass divided by the volume. If you are trying to find the volume, it's the mass divided by the density. And if you're trying to find the mass, it's the density times the volume. If they're side by side, you multiply. So let's take a look at one of these problems. A block of aluminum occupies a volume of 15 milliliters and weighs 40.5 grams. What is its density? First, I like to go through and underline all the information I've been given, all the numerical values I've been given. So we have 15 milliliters. Milliliters is the volume, so I put a V underneath. 40.5 grams. Grams is the mass, so I put an M. And what is the density? Density is what we're trying to find, so I put a D with a question mark. Next, I'm trying to find density, so I cover up density, and it's mass divided by volume. So the only work that I require you to show is this. What numbers did you use, and were they multiplied or divided? Then you just show your answer. So it was mass divided by volume. Oh, wait a minute. Mass is second, not first. They're trying to trip us up. So be careful, make sure the mass goes on the top and the volume goes on the bottom. 40.5 grams divided by 15.0 milliliters. You don't have to show the grams and the milliliters in your work. Just show me 40.5 over 15. Then do your math. Grab my calculator here. And you get 2.7. All right, 2.7 what? Remember, a number without units is meaningless. What? Well, for example, if I told you I weighed 68, you would say I was a liar. Well, I do weigh 68 kilograms, so that's why units are so important. So it was grams divided by milliliters. Those two don't cancel, so my unit is grams per milliliter. Let's try problem number 3. What mass of ethanol, okay, so we're trying to find the mass, that's M with a question mark, will fill a 200 milliliter container. 200 milliliters. Milliliters is a volume. The density of ethanol, okay, so they're giving us the density, is 0.789 grams per milliliter, so that's the density. So we are finding mass, we are given density and volume. So we cover up the mass, and we'll need to use the density times the volume, side by side, so we multiply. So density, 0.789 times the volume, 200. Do your math, and you'll get 157.8. Now, what units are we going to use here? Well, they told us it was the mass. So let's see, we have milliliters, we have grams, and we have milliliters again. So since milliliters is already used twice, it's probably going to be in grams. And sure enough, if we're looking for mass, mass is in grams. Another way to figure out the unit would be to fill in the units. 0.789 is grams over milliliters. 200 is in milliliters. The milliliters cancel and we're left with grams. Personally, I think it's a lot easier to say, all right, we have milliliters, grams, and milliliters. Oh, hey, grams. Number 4, what volume of silver metal, okay, we're finding the volume, will weigh 2,500 grams? Okay, that's the mass. The density of silver is 10.5 grams per cubic centimeter. That's the density. All right, we're looking for volume. They gave us mass and density. Cover up the volume. Mass divided by density. Make sure the mass goes on top. Let's see, so 2,500 grams divided by 10.5 grams per cubic centimeter. Remember, the only work you have to show me is 2,500 divided by 10.5. Then do your math. Get that calculator. And you get 238. Let's just round to that whole number. As long as you round to a reasonable number of decimal places, that's fine. If you can pick my answer out of a multiple choice, that's close enough. Or if your answer rounds to mine or my answer rounds to yours, that's fine. We're not going to worry a whole lot about how many decimal places to keep. So we have 238. What? Well, they asked for volume. Volume is either milliliters or cubic centimeters. This problem had it in cubic centimeters. Another way is to say, all right, we had grams, and we had cubic centimeters. Okay. Or we can figure out our units. If we divide by a fraction, remember that you flip the fraction and multiply. So grams over invisible 1 divided by grams per cubic centimeter is the same thing as times cubic centimeter per gram. Then the grams cancel and you're left with cubic centimeters. All right, finally, number 7. A 12-gram sample of a mineral, that's the mass, is placed in a graduated cylinder with 34 milliliters of water, that's the volume. The water level rises to 36.5 milliliters when the mineral is immersed. Wait a minute, that's another volume. What is the density of the material? So we're looking for the density. Okay, so what's going on here? We have a container of water, and in this we're taking a mineral and dunking it in the water. What's going to happen, the water level is going to rise inside the container. The amount that the water rises is the volume of the mineral. So if it started at 34 milliliters and it went up to 36.5, how much did it go up by? So we do 36.5 minus 34.0, and that gives us an increase of 2.5 milliliters. So this is the actual volume of the mineral that we're actually going to use in the problem. Now it's a normal problem. We are looking for the density, cover it up, mass on top, volume on bottom. So the mass is 12.0, the volume 2.5, do your math, and you get 4.8. Now, what units? 12 was grams, 2.5 was milliliters, so this is grams per milliliter. That takes care of it. Remember, if you have questions, contact me by email or you can call the school and I'll be glad to set up a Zoom meeting with you to help you with the rest of these problems. Have a great day.